Previously, we have set up a volume mount so that all of the data inside this pod, which happens to be in the folder data/db, which you know now is the Mongo database data, we've mounted that so that it's now being stored outside the pod on the host system itself. And we created this silly directory structure just so that we could really see that that data was appearing in this directory structure. One of the real powers of Kubernetes is that we can define a system configuration like this and we can port it, for example, between different cloud providers. We've only chosen host path because we're doing local development and testing, but you saw that when we move across to Amazon, we will be able to change this to, for example, AWS Elastic Block Store. And we're going to have some kind of AWS config appearing here. Now I'll just undo that because we don't need it just yet, but that's a preview of what's to come. That will be fine and quite simple, but there is a bit of a problem in that, of course, in real life, it's not going to be just a single pod which has this kind of configuration. We might have, I don't know, 100 different pods all needing persistent storage. Now what that would mean is if we're migrating from one cloud provider to another cloud provider, we would have to hunt through all of our pods looking for wherever we've referenced persistent volumes, and we'd have to change, for example, host path to EBS volume. And that, I imagine, would be really tedious and difficult engineering work to do. If you like, what we've done in here is we've hard-coded the implementation of this mounting. What we can do instead, if we remove this host path, is we can put in here a pointer to the configuration of how we want the mount to be implemented. And the idea is that if we're pointing to the configuration from here, then we could put that configuration into a file of its own. And so when we move from one cloud provider to another, we just then have to go into the configuration that we're referencing rather than changing it in every single pod. So that's quite a nice idea. And in Kubernetes, it has a jargon term, which is a persistent volume claim. So what we do instead is we use the value persistent volume claim. And this has a nested value of claim name, which is just a label that we're going to make up. But that's going to be the name of the configuration block that we're going to write somewhere else. So I'll call this Mongo PVC for persistent volume claim. This volume is going to need to claim some storage from somewhere, but it's not going to be configured here in this block. The idea is we can now go ahead and create a separate YAML configuration, and it could be in this file. I could do it down here, for example, and add in this PVC. But I think more likely in real life, you'd probably be creating a new file, and I'll call this, let's call it storage.yaml. And in this file, I'll configure exactly how I want the storage to be implemented. So I could have a YAML file here for local storage, and we will do that in just a few moments. And we call that Mongo PVC. So the general point of this is now our workload doesn't have any specific implementation detail of what kind of platform we're running on. Which means when we move from local storage to Amazon, for example, we wouldn't need to make any changes to our workloads, and that's so important. Remember, we might have to go through 100 different pod definitions looking for wherever we've referenced persistent storage. No, instead we'd go into here and probably just create a new YAML file for the Amazon storage implementation, which would have different configuration and different values. So it's really just a level of indirection that we have here, which allows us to keep our persistent storage configuration in a place of its own. But I must admit, I do find it perhaps a little bit overcomplicated, the configuration here. Let me take you through how we would define this persistent volume claim. First of all, it's the same API version as usual, v1. and the kind is going to be persistent volume claim. And we need some metadata as usual, which is going to be the name of this persistent volume claim. And that's going to match exactly what we had in here. And then we have a spec block. Now, one benefit of persistent volume claims that I haven't mentioned so far is that because we've got effectively a whole file that we can work in here, we're able to put much more sophisticated specifications in here than we were using the previous approach that we did before. For example, in the spec block, we can specify that we want a certain amount of hard disk space for this particular volume claim. So we can say, I mean, we don't really need it for this system, but just to demonstrate, we can say that we want certain resources and we would like to request, there's a key here called requests. We can request that we want storage of, I'm just going to go for a random number here, 20 gigabytes, and the GI here means gigabytes. And that's really what a persistent volume claim is all about. We're specifying here that Kubernetes needs to go away and find 20 gigabytes of storage in a persistent volume. Now, the weird thing about a claim is that we don't specify in here how we want the claim to be implemented. You might have been expecting that we're going to put in here the host path and we're going to use that mount to wherever we mount it to. In fact, you don't put that configuration in here because there's a further level of indirection in that that configuration goes in a separate document. There's going to be another document which is at version 1. This time, the kind is of kind persistent volume. And this document is going to be where we say whether we want a local directory or whether we want EBS or Azure or any of those massive number of options that we saw previously. This first document is saying, what do we want? And the second document is saying, how do we want it implemented? In this how do we want it implemented, as usual, we specify a metadata name, and the how is going to be, for this deployment, we want local storage. So I'm going to call this just local storage. And then in the spec, we say exactly how this is going to be implemented. And the first key that I'm going to put in here is the key that determines how we want this storage to be implemented. And we get to choose once again from exactly the same list as we had previously. AWS Elastic Block Store, Azure Disk, or for us in this chapter, we're looking for host path. So the specification is going to be host path. And now we have exactly the same as before. We have the path, which is going to be where we want this to be mounted. Now, I think the last time around, the path was something like /MNT/some directory structure. I think what I will do this time around, so that we can see clearly that our new configuration is working, if I use the same directory structure as before and I make some kind of mistake, it might be that the old configuration carries on working. So we can do anything here. I'm going to go for some new directory structure. Now, in our previous configuration, we had a further field here called type, which we set to directory or create. I'm fairly sure this is the default anyway, because I often don't bother specifying type here, and it just works, but I think it would be better to be explicit. So we're about 80% of the way there with this storage configuration, but there are a few mandatory fields that we're going to need to add here. I realise that building these documents is quite difficult, but there is, as part of the reference manual, a page describing persistent volumes. And there is, if you just do a Control F for persistent volume claims, there's an example YAML document for persistent volume claim right here. Now, as you can see, their persistent volume claim document is a little bit bigger. It has some more advanced fields down here, but I can tell you that this field here, access modes, is required. Now it's not difficult because we need exactly what is in the example here. Access modes followed by a list with one value, which is read write once. Now if you're happy to, in the persistent volume claim, to simply pretty much copy and paste that in, or just type it in verbatim. Now I hate doing that on courses because I should be explaining what all of these things mean. And this field is described in the very same document, and I just did a Control F for access modes. There are only 3 values available here. We've used read write once, but there are 2 other options, read only many and read write many. Now all this determines is, do we want a volume which can be mounted by multiple nodes at the same time? Now, as far as I know, this is a very, very rare need to be able to mount a volume from multiple nodes at the same time. Read write once is going to be your default option in 99 or more percent of the times. Now, maybe when you go further with Kubernetes, you might find a use for read only many and read write many. But just to mention, going a little further down here, there's a matrix here of the different types of volumes that we can work with. And looking at the first line here, you can see that AWS Elastic Block Stores only support read write once anyway. So you really don't need to worry much about this field other than you need to have it in the documents. So that's in the persistent volume claim, but it turns out that we also need the same thing in the persistent volume document as well. Here I am back on the web page. This is one of their examples of a persistent volume, and you can see here that access modes needs to appear in this document as well. So that's going to go under spec. So I hope you're happy with that. That's a bit of a non-brainer. Now the last thing that's required, and I think I'll use the same example to illustrate this as well, is that we also have to specify in the persistent volume what capacity this volume is going to be. And it's just the tag capacity followed by storage and the size of storage that this persistent volume is going to offer. This isn't that interesting for a host path because of course this is just a directory structure. So in the case of this configuration, I've just pasted in from the document there, but if you need to type it in, it's capacity colon, then on the next line storage colon, and let's make a change. Let's go for 20 gigabytes. That's just going to allocate 20 gigabytes on this directory structure, which isn't that useful for a host path. But when we go across to a cloud provider, we will need a more advanced configuration to make it happen. But the capacity in that case becomes really important because that's how much space is allocated on your cloud provider for storage. And we'll see an example of that later. Now it's important that you change this to 20 gigabytes because if you remember from above, in the persistent volume claim, this is where we're asking for some storage. We asked for 20 gigabytes of storage. So for that to be fulfilled by Kubernetes, it needs to be able to find some matching persistent volume which has at least the storage capacity required. Now I realise this is getting all a bit complicated, and I've been working with this for a long time and I always tie myself in knots and get quite confused as to what's going on here sometimes. But the important thing to remember is that we have 2 separate needs that we're expressing here. I'll repeat, the first document we have is saying, what do we want? What are we looking for to fulfill our requirements for our Mongo container? Whereas with the second document, we're saying what physical storage do we want to have in our Kubernetes cluster? So actually, these 2 values are different because what we could do is we could say, oh, well, actually, this persistent volume is going to be 100 gigabytes in size. Now, as I say, it's not really relevant to a directory structure, but it's certainly relevant if we deploy this to the cloud now, we would find we'd have a hard drive created, an EBS volume, and that will be physically 100 gigabytes. So this is physical storage. Now, up here, Mongo is just saying, oh, I need 20 gigabytes of storage. Kubernetes, please fulfill it. And I'll show you how this works in a second, but it will search around for a match. Oh yeah, here's a match here. There's enough physical storage here to fulfill this requirement. The other way around would not have worked. If we were asking for 100 gigabytes of storage, but this particular hard drive was only 10 gigabytes in size, then this would not be a match and it would not be a suitable implementation for the requirement that we had. So I better change this back now before I forget. We'll make both of them 20. But yeah, I think it's quite hard to understand this when you first come across it, because we're just doing simple basic local testing. But when we go into a cloud environment, this separation becomes really important. You could imagine that the administrator of the cluster is in charge of provisioning the hard drives and so on, and they can just work in this field here. Whereas the developer who's responsible for setting up in this case, the Mongo container, they're working in this document. They're just declaring their needs. So it's actually quite an elegant system, this, but I must admit the configuration of it I find quite complicated. There's just one final thing that we need to do here. You'll notice that this persistent volume claim does not reference the persistent volume at all. The persistent volume we've called local storage, and the persistent volume claim doesn't reference that name anywhere. So in the next video, I'll show you how to link together the persistent volume claim and the persistent volume using a storage class.